So we're going to leave graphs for a minute and just look at functions and how do we evaluate functions given different values and expressions. We're going to come to this function, and wherever there's an x, we're going to replace it with negative 3. So f of negative 3 equals 2 times negative 3 plus 5. And then you just do arithmetic. So f of negative 3 equals negative 1. And remember from the graph, what does that mean? That's an ordered pair of x is negative 3 and y is negative 1. So f of 2 would be 2 times 2 plus 5. So again, f of 2 is 9, so another ordered pair on this graph is 2 comma 9. But what the heck do we do with x minus 1? Well, we follow the same procedure. Wherever there's an x, we're now going to put in an x minus 1. And I'm going to go ahead and distribute and collect like terms. We are not solving an equation. That's the answer. It's an expression. It's kind of strange. We're going to do that a couple more times on the next example. So, everywhere there is an x, we're going to put in negative 3. And we're going to follow our order of operations. So we're going to square negative 3, which is positive 9. That's 9. So that's 19. So f of negative 3 is 19. That means when x is negative 3, y is 19. So that is a point on that graph. But what about f of negative x? We're going to do the same thing. Okay, so we're going to have negative x, then we're going to square it, minus 3 times negative x plus 1. So we're going to square that. That's going to be positive x squared. That's plus 3x. There's no like terms. We're not solving. That's it. Again, a little weird. Okay, now f of x plus 5. All right, so we have it's going to equal to this squared minus 3 times this plus 1. So everywhere there's an x, I'm putting in an x plus 5. Might not have allowed myself a lot of room, so I have to FOIL that out. Remember, that's x plus 5 times x plus 5 minus 3 times x plus 5 plus 1. So go. Again, FOILing that out, collecting like terms, distributing the negative 3. And I should have put equal signs here. So again, didn't leave myself a lot of room. So f of x plus 5 is x squared. And then 10 minus 3 is 7x. And I've got 25 minus 15 is 10 plus 1. Not solving, just simplifying. Our last example, same idea. Everywhere there's an x, you're going to replace that and then simplify it. So we have h of negative 1. So that's positive 1 on top. That's negative 2 on top. I'm sorry, negative 2 on the bottom. Okay, h of 4 is 4 squared over 4 minus 1. I know you don't really need those parentheses on the bottom, but I just want to emphasize wherever you put an x, you're putting in that expression. If you put parentheses, so in case there's exponents or something, you won't forget them. So we have 16 over 3. And then h of negative x, and this is where those parentheses are important. So this is positive x squared over x minus 1. Now, would you have gotten a different answer if you didn't put those parentheses? Yes, you would have. And it would be wrong. If I just wrote this, believe it or not, that would be negative x squared. Oops, now left out a negative there. Okay, this way it says just square it and then make it negative. This way says square a negative thing, which is a positive. So again, this is wrong. With my negative there, that is correct. We have the vertical line test. We have intercepts, finding the domain in the range from a graph, and then we're evaluating those functions.